Okay, so here is a lesson on intersection of two planes. Okay, so we have a couple situations here. I'll describe them. So the first situation is where the two planes intersect at a line. Okay, this is probably the most common one. If you have two random planes, they will intersect at a line. The other one is if they're parallel, then there is no intersection. Otherwise, if they're parallel and they share a point, then they are coincident and the plane is the intersection. Okay? So coincident planes means that the plane itself is the intersection. Okay, so those are the three situations. So I'm going to put down here two equations of planes that I've just randomly chosen and see what happens. Okay? So the first thing we want to do is solve for x, y, and z for the points in common in the two planes. So you're never going to get a point of intersection for the two planes. You're always going to get either a line, a plane, or nothing. Okay, so when I look at these two equations, one is not a scalar multiple of the other. The normals are not the same. So let's compare the normals first of all, to see if they are parallel. Okay? So the normal 1 is 2, negative 3, 1. Normal 2 is 1, 1, negative 2. Well, to get a 2 from this 1, I'm going to have to multiply this vector by 2. If I multiply a 1 by 2, I'm going to get 2, not negative 3. So they are not scalar multiples of each other, which means they're not parallel. Okay, so the planes are not parallel or coincident. So that means we're going to have a line of intersection. Okay? All right, so this is basically what we have. So because there's a line of intersection in 3 dimensions, our equations of lines are going to be in parametric, vector, or symmetric. There is no Cartesian equation of a line in 3 dimensions. Okay, so we're going to try and find the parametric version of that. In parametric, we need a parameter. So for these equations, I'm just going to pick one of the variables here and let it equal to t. Because there's 3 unknowns here, we can really only solve for 2 unknowns in 2 equations. So I'm going to let z equal to t. You could let x equal to t or y equal to t. And it's a good idea to check that and see if the lines that you get are the same. So I'm going to let z equal to t, and this is basically the parametric equation for z. Z equals z naught plus ct, so in this case z naught is 0 and c is 1. Okay, so sub that into our 2 equations and bring it over to the right side, and we get this. So 2x minus 3y equals 4 minus t. That's from subbing z equal to t and bringing it over. And then x plus y equals negative 1 plus 2t. Again, we subbed in t for z and brought it over. Okay. So now, how do we solve this? Well, when you look at this, you've now have 2 equations with 2 unknowns, but the constant term has a t in it now. Okay, so you're treating the t as a constant, even though it is a variable, it's a parameter. Okay, so now we're going to try and solve for expressions for x and y in terms of t using substitution or elimination. Okay, so we're going to eliminate in this one. So let's eliminate x. So if we take 2 times equation 1, 2 times equation 2, and go 1 minus 2 times equation 2, we'll eliminate the x. So that's what I'm doing here. Okay? So there's equation 1, and there's 2 times equation 2, and now I'm going to subtract. So the x's go away. I get negative 5y. 4 minus negative 2 is positive 6. And then the t's give me negative 5t, and that simplifies to y equals negative 6/5 plus t. And that's our y naught plus bt. So b is 1, y naught is negative 6/5. Okay. Now we can do elimination again, or we can use substitution. So I'm going to sub that into equation 2. When I sub that in for y in equation 2, I get x plus negative 6/5 plus t equals negative 1 plus 2t. Solving for x, we get this, 1/5 plus t. There's the x naught, and the a is 1 in this case. So x equals x naught plus at. A is 1. So that was kind of convenient that a, b, and c all equaled 1. That wouldn't be true in general. Okay, so now you can write the line of intersection is this set of parametric equations. And if you need it in vector form or symmetric form, then you just convert it. Okay. Now, what happens if the planes are in different forms? So, say you've got plane 1 is 2x minus 3y plus 7z equals 4. That's Cartesian form. And the other plane is in parametric form. Well, you can take these expressions for x, y, and z and put them in for x, y, and z here and try to solve. Okay? Or you can convert this to Cartesian form and do it the way we just did. So there's two methods for that, and you should give that a try. Okay, that's it for that video.